Speed, strength, stealth and power. The submarine is a mean machine. It takes man into a hostile world. Today's submarines are technological masterpieces. This is a machine designed like no other.
We don't build prototypes. The submarine has to perform first time it goes to sea.
For 200 years, it's been a process of trial and error in the search for perfection, evolving to fight two different but deadly foes. The massive force of the ocean, and an enemy scanning the depths for the telltale signs.
Once we give ourselves away, that's the end of the game. You may as well go home.
Have we built the ultimate submarine? This is HMS Trafalgar, one of the Royal Navy's ultra-quiet, super-fast submarines. Its weaponry can take out targets 1,000 miles away. Its nuclear-powered propulsion delivers an astonishing 15,000 horsepower. This is where we are today, but how have we got here? Submarine design has been evolving for centuries. The dream of travelling underwater existed long before it became a reality.
Man had fiddled around with the concept of the submarine for hundreds of years.
All kinds of prototypes have been built, but they all hit the same stumbling block: how to devise an effective means of propulsion. In 1897, an Irish-American inventor had a flash of inspiration.
And then along comes a man called John Philip Holland, who had the notion of marrying the internal combustion engine with the battery. And therein really lies his genius.
Here's Holland 1, a product of that genius. Built in 1901, it used a petrol engine to drive it on the surface. But this engine did a second job. It charged an electric battery, which in turn would propel the submarine underwater. Holland's early designs had been driven by a desire to build a weapon to attack the hated Royal Navy. But his genius was such that even the British government put aside their reservations that these were ungentlemanly machines. Holland 1 was the first ever Royal Navy submarine. But its great strength, its petrol engine, was also its Achilles heel.
Well, this is a little trough full of petrol. Very volatile, gives off lots of fumes which affected people on board the submarines, catches fire very easily. A lot of explosions and fires on the early submarines.
A safer, more stable fuel was needed. The obvious candidate was diesel.
And this is a trough of diesel. The important thing is it gives off much less vapour, it's much less volatile, has a higher flash point.
It takes the concentrated flame of an industrial blowtorch to set it alight. First used by a French submarine in 1903, by World War I, diesel was the fuel of choice in every Navy's submarine fleet. But it was the German Navy that would really exploit the diesel-electric engine. By World War II, their U-boats had evolved into highly reliable, deadly submarines. They wrought havoc in the Battle of the Atlantic. But even the U-boat was still reliant on electric batteries for underwater propulsion.
The big limitation that a diesel submarine had was that it had to charge its batteries. It was totally dependent, at the end of the day, when dived, on its batteries.
And to recharge those batteries, the submarine had to come back to the surface every 24 hours. The diesel engine that charged them needed to take in air.
The time that a diesel submarine was most vulnerable was when it was recharging its batteries.
Underwater, the submarine was almost invincible. On the surface, it could be a sitting duck. By the end of World War II, the days of submarine supremacy seemed numbered. Then came a new kind of fuel, nuclear power. With it, a submarine need never surface again. The American submarine Nautilus was the first to use nuclear propulsion.
In 1955, when USS Nautilus made the famous signal underway on nuclear power, it was announcing that the world had seen its first true submarine.
Nautilus marked a step change in the way a submarine could be used.
With the arrival of nuclear submarines, you got a submarine that was effectively a true submarine. It really was independent of the air, of the atmosphere, and that gave it a tremendous capability.
This is one of Britain's first nuclear submarines, HMS Courageous. Built in the late 1960s, its energy source was equivalent to the output of a power station. Rupert Best was one of the Royal Navy's nuclear pioneers. He was a key member of Courageous's construction team and went on to captain her during the Falklands War.
The thing that really struck one in seeing her launch and then joining her was how very much bigger and a much more substantial vessel she was than anything I'd served in before. And that size and, of course, the capability of nuclear power gave her qualities which a conventional submarine would never have had and never could have.
Submarine propulsion had been transformed. With unlimited power, the submarine could go anywhere in the world, and for the first time, it was faster than a surface ship. Now, the ultimate submarine was becoming a reality. Of all the threats the submarine must face, there is none more dangerous than the sea itself.
They live in a naturally dangerous environment. The sea is just waiting to get in, so you've got to keep her out.
A submarine's hull has to withstand the enormous forces of water pressure. The deeper it goes, the greater the strain. At 200 meters depth, there's a force of 150 kilograms pressing in on every square centimetre of the hull. At 500 meters, this is more than doubled. Submarine designers had always built their hulls to a safe theoretical working depth. But what would happen if a submarine went beyond this limit? In 1945, they decided to find out.
At the end of World War II, the Royal Navy took a number of redundant S-class hulls and literally put them into deep water to wait for the moment that they crushed.
These dramatic tests gave us startling insight into the limits of the pressure hull.
You had an absolute percussion. It was like a gun going off. Literally went from creaking pressure to snap. The whole thing imploded. In one sense, from a submarine point of view, that's quite reassuring. At least it'd be quick.
Paul Morehouse builds submarines to order. The thickness of the steel he uses depends on how deep the submarine needs to go. The inner core of the submarine, the pressure hull, has to be able to withstand it.
This pressure hull here is designed to dive to 300 meters, and it's made of steel, high-grade steel, which is 16 millimeters thick. And it needs to be all of that because the pressure outside is 30 times as high as it is normal atmospheric pressure.
But weight limits how thick the steel can be.